Hi there, this is Penelope. This is the third in the series of videos DE4102, Trimester 2, 2001-18 exam. This is question 3. Okay, solve for x. You can either just kind of know the answer and just go straight to it, which is fine in this particular case because it's only worth 1 mark, or you can work it out if you couldn't see it. So when we've got something that we don't know as a power, we take logs of each side. It doesn't matter in this case whether you take natural logs. So I'm going to bring that down and say that that's natural log 5 is equal to x times natural log 3. I could probably subtract now I need to factorize. Now divide both sides by the bracket, so I've got x equals 0. Check it out. It's the only number that will work for. Okay, now part B. Sometimes the hints are not terribly helpful. Sometimes you just have to think about it for yourself. First up, you can't multiply those two together because they're not the same base number. So you have to be a weeny bit more sneaky and remember that 7x minus 1 is the same as 7 to the power of negative 1 times 7 to the power of x times 3x equals 3. Now this, I suppose if you do follow the clue over here, it does mean that you're likely to think that. These we can now combine as to be 7 times 3 to the power of x times the 7th equals 3. So 7 times 3 to the power of x equals 3 times 7. Okay, 7 times 3 is 21 to the power of x equals 21. The only thing that x can equal is 1. Solve for x. X to the power of, 11 to the power of 2x minus 3 equals 9. Same thing, use the rule, bring it down to the front. So it's 2x minus 3 natural log, or log, doesn't matter, equals natural log of 9. 2x minus 3 equals natural log 9 over natural log 11. 2x equals that plus 3. And now we need to divide it by 2. Now, we want it to be all over 11, probably is the easiest thing to do. So 2 times, oops, it's actually 2 divided by, so 2 goes on the bottom. Let's make natural log 11 our denominator. Okay, so 3 needs to be over natural log 11, so just multiply it by that, just to get it all in the one place. It doesn't overly matter if you don't, and so our final answer would be 1.958. Now look, all the way through this paper you need to watch how you need to record your answer because it changes every time. Just watch that. In fact, let's do that. Okay, so watch out for that. Question D says solve for log to the base 10 of s squared equals 9. To undo squaring, we square root it, so log to the base 10 of s equals the square root of 9, which is plus or minus 3. Don't forget, plus or minus 3. So that tells us that log 10s equals 3, or log 10s equals negative 3. And remember that we undo logging by taking to the power of 10. So s equals 10 to the power of 3, or s equals 10 to the power of negative 3. And you can leave it like that, or you could write it as 1,000 or 1 over 1,000. Solve for P and Q. Now you are given what looks to me like two simultaneous equations and your first thought is to line them up and multiply by this and do that sort of thing, but you can't because it just doesn't work. 2 marks, not very long, so what we need to do then is not eliminate but substitute. We've got 3p minus 2q equals, oops, that's a q, equals 1, and p equals q squared. So we're going to substitute that into there. Now we have 3q squared minus 2q equals 1, which I can bring over. Now, I can either use the quadratic formula or I can factorise. I think in this case it's just as quick to factorise. So, factors of -1 can be +1 and -1. Just check that that works. Blah, 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 blah. Yes, it does. So that means that q is equal to -1/3 or q equals 1. Go back. Check your answers.